Good afternoon, everyone. Strangest story I think I've ever done. The Arctic Ocean sea ice is not freezing in October for the first time in known history. The article points to ocean salinity, but it's well within the known averages throughout the year. Even looking back 2011 to 2017, same salinity. Another anomaly this year, Greenland ice season stopped a month early, and the record ice gain in August. Crossing out those two possibilities, it leaves us with ocean current stopping or reversing. Moorman and the Spitsbergen current. Because looking on Null School, there is something moving with such velocity that it sticks out in such a way that nature running in straight lines, not normal. Until you look at the emanation point of the Eurasian Basin and the Gekkel Ridge, prior split in our Earth's crust, a known hot spot in volcanic ridge, the same area that the strange current's coming from, has our Earth started to rip again, entering into this grand solar minimum. But a sigh of relief is Antarctic sea ice rebounds above the 1981 to 2010 average. And with the U.S. election just a few weeks away, I think you'd agree, whatever the outcome, things are going to be rough for a while. So if you're worried about your finances taking a hit, you should look at protecting your savings, especially your hard-earned retirement fund. The team at Noble Gold knows how to do this, and they've done it for thousands of other people before you. With every qualifying IRA or 401k rollover, Noble Gold is gifting a 10th ounce solid gold American Eagle proof coin. Grab the phone and give Noble Gold a call now. 877-646-5347. And you'll also find the link in the description box below the video. So this video is going to be a group effort. I'm looking for information if anybody would know or has conjecture as to what is happening up here. I'm going to present facts I'm finding, but a hypothesis of mid-ocean ridge crustal splitting, causing unusual currents backing, stopping flows into the Arctic right now. Because off Severe Weather EU, this story caught my attention right away. Arctic Ocean sea ice is not freezing in October for the first time in known history. So investigating causes, first thing I was looking at global sea temperatures. But anywhere in the dark blue at the far north of the map there, around 0, which is freezing or below, and you'll see a little bit of lighter blue, almost teal there. That's about 1 degree Celsius, a bit warmer than normal. And then jumping over to the sea ice thickness, you'll see that massive gap from Alaska all the way over to Norway. Coastal regions should be freezing first. Coastal shallow anomalies not freezing. Sea ice concentrations here on the 26th. Now that yellow line that you're looking at is the old 1981 to 2010 average. But the prior map that we saw isn't as detailed as the one off NSIDC here that does show some coastal ice beginning in the same days. And if you go over to Null School, you'll take a look at the ocean temperatures there. And even coastal, everywhere I'm looking, there at least 0 at freezing or a little bit below. Darker blue, obviously, is cooler temperatures. And when we get down near Norway, we get into the warmer currents that are coming off the North Atlantic current out of the Atlantic Ocean, which should be up into sinking and circulating water within the Arctic Basin. So if it's not temperatures, because you look and it's not all outrageously above anything, it's at freezing. So wait a second, let's go to the second possible connection here for the change, salinity, ocean salinity. And this graphic was linked in the Severe Weather EU story. And you notice a bunch of different salinity ranges inside the Arctic Circle. So at the far north up there, you're going to see that real dark purplish black. That's going to bring us down to, let's say, 25, 26 grams per kilogram. And before we go any further, the averages normally are 34 to 36 just in seawater itself. So a quick seawater graph, if you will, here. So the measurements here are going to be in grams per kilogram. So they have 1,000 grams of seawater, and then how many grams in solution of salt are inside that? Well, the world average is 34.4. And it can get as high as 36, and it can go down as low as 25. It depends if there's rivers coming in from a continent into the coastal areas, which would dilute it and we get more brackish water. But if we're talking about straight up seawater, we're looking around, let's say 34 to 35 is the global average. So when you look at the Arctic Basin coming in on the North Atlantic current, south of Greenland there and to the right around Norway, Sweden, Finland, it's getting a little on the far edge there, around 36, but then it tapers off through the Arctic right into that 34 range or so. But as we get toward the Kamchatka Peninsula on top of Asia there, pretty much north in that map, you get that darkish purple there. It's below 27, right around 25. And pulling out another Aquarius satellite reading here of monthly sea surface salinity. This is in July of 2020. You see those same areas where it's heavier salinity coming in between Norway and Scandinavian countries, and then it tapers off, and then you get into those purples again, which is lower salinity. So everything's matching so far as normal. And I dove into a couple reports here comparing the different satellites and projects measuring ocean salinity, and this goes back to 2011 through 2017. And you'll see it has the same fingerprint. Heavier salinity coming in between Greenland and the Scandinavian countries, tapering off, and then lower salinity as we round it over in the Kamchatka Peninsula area, north up in Asia over into Alaska. So it doesn't seem to be super abnormal there either. And this information was off the Aquarius spacecraft. I've linked everything in the description box below in case you want to go into the interactive models there. And the latest that I could pull out through Mercator was the 24th, which is just a few days back, so it's not going to be that much of a difference in the grand scheme of a full ocean circulating. But another anomaly that was happening in Greenland this year, so if you say, wait, is Greenland melting? It's all that extra water coming out, creating all the havoc. Hold on for a second. Back in August of this year, that giant spike above means that Greenland gained ice for almost 2 weeks in August, well above anything that has ever been seen before. Now, this really didn't make too many headlines, although it should have, but if it's above that zero line, it's gaining ice. And it was such a shock that the melt season in Greenland ended nearly a month early this year. And if we look where the blue line is, bringing us into the next new season from September forward, you'll see that the blue gains are outpacing the 19 year. And I do need to put it into perspective here, because if we are looking for causation for strange ocean currents stopping, backing, or changing, new meltwater in there would be definitely one of those. But if we look at Greenland surface melt, the orange line is the largest amount of melt in 2012. 2019-20 so far is the blue line. So there was far more melting in 2012. And then if you scrunch all these last years together from 2016, 17, 18, 19, and then this year, the lightest blue line that's really bold is this year in comparison to the last 5 years. And you can definitely see that's trending on the low side comparatively to the last 5 years. To put it into context how rare of an event the ice gain was in August, the Greenland melt extent, they don't even have anything in their algorithm for gains during that time. So I showed you that massive spike at the end of August for almost that week and a half. That should be sliding in after that large spike, but it doesn't. There's nowhere for this chart to go negative. They need to upgrade their algorithm to start taking into consideration ice gains. Now keep your eyes on August, and I'm going to flip right back over into the surface mass balance again. And you can see that giant spike in August is not on that chart, nor is the end of August with the gains. It's never been programmed in for such a thing because it's also the first time it's happened. So what are the chances of these two first time ever recorded events happening within months of each other? And if we do take a look at the accumulated over the year, 2020 is the blue line where it's already starting into the newest season, 2019-20 the last year. But if you notice in August, it's right along that 1981 and 2010 mean average line, but then you get that spike right into and touching the 1981 to 2010 average line. That spike is visible even on this chart, but there's no way for it to be added in. Now, personally, I feel NSIDC needs to upgrade their algorithm. We're literally in uncharted territory, pun intended. So check those two possible causations off. Here we go. I'm going to go to a third one, ocean circulation currents. I believe this is the cause right here. And this is where I want to get your opinions, ideas, so we can compare and try to find an answer together on this. Because if we go all the way over where it says Asia, and this map is kind of deceiving because that should be wrapping around to create an Arctic circle, but it's a flat map. So if you're looking at the Murman current, Zemia current, and the East Spitzbergen current, these are the areas that are disrupted right now. And something's happening with the water currents coming in from the Atlantic that are not sinking in the way they should. And when we get a better glimpse, I'm going to take you around to the Laptev and Kara Sea. What we're looking where it says North Pole, that number 4 right there. I want to be a little more, well, shall we say, precise with it. So I'll bring up an older Arctic map, which I have linked below. You got some amazing maps. Linked them all below, but we're looking at about 140 degrees. On the compass here is where we're going to be referencing for the rest of the video, looking at the Arctic currents. And grabbing this from the 1950s, we'll also see some of the previous current charts here up through the Laptev Sea in the Markov and the Nansen basins. This is disrupted. Something has caused it to speed up its flow in a very unusual way. But before we jump in there, this is a map from 1736 called the Bowles map. So you can get a good indication of what they knew about the Arctic back in 1730. I like at the top there where it says, parts unknown. So to read such a statement in the beginning of the video where it's the first time in known history that the ice did not come in October, we're going back to 1736 on this. So the focus of the current that's disrupted is in the Laptev and the Kara Sea. So if you see where it says North Pole and you go directly east of there toward the tree line data, that's the green line. And I had the orientation wrong on this for a minute there, but you can definitely see the island chains in the two different seas. Looking at the ocean currents on Null School, I saw this strange vertical line. I said, I never saw anything like that before. And here I oriented it the correct direction this time. Nature doesn't work like this. Nature does not go in straight lines. And the velocity coming out of the Arctic Circle is strange anyway, but the occulter disk, why are they covering that up? What's up there that's being covered? Okay, the periphery of it's coming out to show you the speed of the water is so fast that it's literally off the chart into the reds, blowing straight, and then it looks like it's clipping off the island and bouncing back. That's how fast the water's moving. That's strange. And when you wide out here on Null School, you can sort of see it. But the only reason I was looking up here and looking for this specific thing was I was trying to find what is the disruption for this sea not to refreeze right now. Because the other currents are visible. The scale, and you see the coloration, is pegging the scale of how fast the currents are moving. And again, the blocking out of the entire North Pole, why are we not allowed to see that? What's up there that's being hidden? That should be another whole question. Probably do a whole video on that. Until you start to uncover what's under that basin there, well, it's the Eurasian Basin. And you might say, well, what's the Eurasian Basin? That is a deep water canyon. It's the deepest area in the North Pole. Prior, millions of years, there was a deformation or a split in the Earth's crust, and it left that depression there. What do we have today? The Gackel Ridge, an enormous amount of undersea volcanoes along that ridge. And guess what? You see where it's exiting right into the Laptev Shelf? That current is coming out of this area, heading east into the Laptev Sea. Gackel Ridge, it's nothing but volcanoes. And there were some massive eruptions there. They call it the volcanic complex just a few years back. So my question to you is, knowing that there's 3 times more water in the Earth's crust than there is on the oceans above, could there be a rift happening in the Arctic Ocean, sending that water being pushed out from the Earth's crust at such velocity to create that new current that is now backing up the other currents, preventing the regular circulation, and that's the cause, for the first time since at least 1736, that we are seeing ice not being formed in these seas in October. And the World Bank wants to take us into the Great Reset at this exact same time. It's a little quirky, everything happening on the planet, and now this on top of it. I don't know if that's a coincidence. But something that we should be jumping for joy, and this should be on the front page of every newspaper, but it's not. Antarctic sea ice extent above the 1981-2010 average, meaning it recovered this year. That's the light blue line. Well above what is considered the benchmark for ice gain or loss in our oceans during winter. I think it's a crustal split with a crustal aquifer, if you will, blasting out water in a very small sliver, causing that what is considered vertical current. That's what I think it is. I'd like to know your opinions. Leave it in the description box below. We'll try to figure it out together. But all of us, we need to eat, and so many emergencies and strange disruptions are happening across the planet. Are you ready for it? Do you have any food stocked in your house in case you can't get to the store, in case the store is closed for some reason? My Patriot Supply and Adapt 2030, the 2-week or the 4-week emergency food supply. It's a great way to support the channel. I do appreciate you watching tonight. Also, the maps, the older maps, the links are in the description box below, along with the link to My Patriot Supply emergency food storage. Hope you got something out of the video, and I'll see you next time.